So what I'm going to teach you about today is a continuation of what Jeremy Keith just taught us about, which is responsive web design. Yes, you should build your sites responsively, but it's not just about design, and that is kind of what I'm going to be talking about. So if you want the slides later on, and I'm also going to reference other decks that I have put together. My name is Estelle, and I am one of the only web developers named Estelle, so I got my own name on GitHub. And you just go to estelle.github.io, and all of my presentations are there. So there's about there's probably around 30 presentations there. And this one is called Responsive Web Design is Not a Panacea. And of course, my computer's working. There we go. So I write books, and mostly the reason I talk around the world is because I am a Twitter whore, and I like when people follow me on Twitter, so please do, at EstelleVW. Okay, so I tweeted this right before I actually proposed this talk the first time, which is, just because no one uses your mobile site doesn't mean that you don't need to improve it or create one in the first place. Maybe no one uses it because it's a really bad experience. I should have said politely, but I only had 140 letters. So the BBC actually figured this out. They cut the size of their website. They created a responsive website, and they reduced the size of that website and the latency from about 150 requests to 70 requests, about 1.8 kilobytes, 1.8 megs to about 700 kilobytes. And look what happened. It's not that people didn't like to use their website on their computer anymore. Desktops went down by 7%. But that 7% was actually people who just moved over to iPad or tablets and mobile devices and phones and because now they had a good experience. But that good experience was not just a squishy design. It was a responsive site. So let's talk about what makes it responsive. If you want to design responsively, this is what you have to deal with just for Android. And this looks really scary. But if you follow what Jeremy said, which is you enhance, this isn't scary at all. So this is from one website. This was the different size Android devices that reached their site in a period of time. And these are all the devices that hit. And you can't even see the little dots in the right-hand corner because there's so many unique devices. But what was interesting is basically this was the aspect ratios. So when you're doing these designs, the design point of it, you really are dealing with very similar aspect ratios. So that's what you really have to think about. You don't have to think about the fact that you have a 300 pixel wide, a 400 pixel wide, a 500 pixel wide. And you shouldn't be thinking about that anyways because you might have a 521 and a 527. So why responsive? Responsive because it really doesn't matter what hardware your users are on, what network they're on, where they are located in the world, or whether they have an impairment, whether it's visually impaired, as in blind, or visually impaired as in myself, and I need to wear granny glasses when I read. Make your site so that it's zoomable. Make your site so that no matter what network they're on or what hardware they're using, they can access your site. And also geography. Geography is really important because there's places in the world where they don't have good networks and where they can't afford good hardware. Okay, so this is what we originally had. We had these sites, and when we checked them on mobile phones, this is what they look like. It just shrank down because by default, most devices think that if you don't tell a mobile device what size your website is, it's going to think it's 980 pixels wide, and it's just going to scale it down. So the first step to making your site more usable is basically put the viewport meta tag in. The viewport meta tag, you can say device content width equals device width and user scalable, and the answer there is yes. It's not no. Okay? You put yes because you want your users to be able to scale your site. Unless it's a game, it should be scalable. Now, what's wrong with this is that meta tag is presentation. So where there's actually going to be an @viewport rule, which is not fully supported in all browsers yet, but which will take the exact values. And I have 2 resources down there. I'm not going to go into that fully right now, but soon we should be taking out the meta tag and putting in the viewport, but we're not there yet. But what that does is it basically takes this and says, you know what? My screen is actually this small, so this is what it's going to show. And that's not really responsive, is it? So there came a responsive design. You probably have read Ethan Marcotte's article on a list apart. And this book actually came out before that article came out, which is by Zoe Gillenwater. And everything Zoe ever has produced is amazing, and I highly recommend that you all follow her and read her blog. But she came out with a book called Flexible Web Design a long time ago, and just like Ethan Marcotte, the idea is fluid grids, flexible images, and media queries. And people are doing that. We have mediaqueries.com if you want to see well-designed, responsive sites. And sometimes these are actually live pull-ins, so you get weird things that show up. I never saw the little thing in the upper right-hand corner before. So this site shows you nice examples of pretty websites. But they're not fully responsive. They're responsive in terms of the fact that if you shrink the, if you shrink the screen, like we did with Disney here, Disney gives you a different design when it's shrunk and a different design on a full screen, right? That is responsive design only, because what happens is this is what they're pulling in. They're making 138 requests on a mobile network, 155 on a desktop, 5.2 megs. Who wants to put 5.2 megs on their phone when they're over Edge or 3G, or when they're traveling, or when they are like me in a foreign country paying for a data plan? Actually, I didn't even pay for a data plan. I was just like, forget it. I'm just going to not be online and actually enjoy the city. And 13 seconds to load. That was over 4G when I tried that. Oh no, 43 seconds. That was over, I don't remember what I was on. But 43 seconds, who would wait 43 seconds for a page to load here? No one, okay. That was my point. So, when I looked up what responsive web design was on Google, it said to see responsive web design in action, basically shrink and expand your screen and see what happens. What that really does is it means that your site is squishy. It doesn't mean it's responsive. So this was another use of the word sucks. Hi, I've been on 1 or 2 bars of 3G service for the past week. And let me tell you, your website sucks. Yes, yours. So if you're not thinking about what you are actually sending down the pipes, your responsive web design is pretty, but not functional. So responsive web design is not just about design. You have to think of latency and bandwidth. You need to think about memory, battery, and actual responsiveness to the human touch. So here's another example. Newsweek put a lot of effort into it. Looks really good. But again, their narrow site actually pulls in 6 extra calls because they've added media queries for their smaller site. They did not go mobile first. It takes 2.8 seconds, but on my Wi-Fi. I didn't actually test this. Wired does it a little differently. It actually does user agent sniffing. And once it sniffs, again, it gives you a bigger site. So I don't know what they're sniffing for. So I took a look at HTTP Archive last night, and I looked at the statistics for this September versus September of 2011, and our websites have increased by 227%. The average website right now is 1.86 megs. The average website in 2011 was 816. That's 1,180 kilobytes of images versus 490. That's 292 kilobytes of JavaScript versus 144. We're sending too much stuff that we don't need down the pipes to our mobile devices. So this is kind of one more time to prove my point. When Google, they tried this thing out called YouTube Feathers. And they reduced the number of requests from about 122 requests to 12. My numbers might be wrong, but the whole article is here. So what happened? They noticed that latency went up by 2 whole minutes. You're thinking, what? They reduced their number of requests by 90% and increased by 2 whole minutes? When they looked at the stats, what they discovered is that people in Siberia were finally using YouTube. Because they made their sites accessible to all users were now using their website. So just because no one is using your mobile site doesn't mean that you don't need to improve your website. It might actually mean that you have a bad experience. So the too long didn't read of that article is the last sentence. By keeping your client-side code small and lightweight, you can literally open your product up to new markets. That's what they did with Feathers, and that's what you can do by improving your site. And one more, I just titled this Duh, which is this company, and I don't know which one it was. This was just a tweet that I saw and had no reference, so I just copied it, and I don't know where it's from originally. But this company increased the size of their site, and duh, the size of their site is on the right side, and how long it took to download is proportional. So the moral of that story is make your site smaller so that they download faster, because speed is a feature. It's actually one of the most important features, because if they're not going to wait to download your site, they're not going to buy your product. If it takes too long to download your site, they're not going to choose you as to do business with. So we want to reduce the size of the request, we want to reduce the number of requests, and we want to reduce the number of DNS lookups. There's many rules that have been set up. You probably know page speed, and you probably know why slow. But if you don't, you can hover over all of these, and the rules are listed under there. Many of those rules have to do with input and output. What comes from the server to the device and what happens on the server. What I'm going to talk about is the assets that are coming through. So not what's happening on the server, but what's actually the pipe, and then a little bit about what happens on their phone. So I'm going to talk about making fewer HTTP requests, reducing DNS lookups, and not scaling images. So making responsive images is not just about making them squishy. You want to improve the performance of your images. Step number 1, which can reduce the file size over the pipes by 70%, is gzipping them and compressing them. So you compress them originally, and then you gzip them. Very simple to do. Don't download images you're not going to use. If it's a background image, to not download an image, you simply make the parent, so the element that has the background image, you make the parent display none. If the element itself is display none, it will still download the background image. So you actually you have to make it one level down. And only load the images you need. So we are going to have the picture element very soon. It's still under flags, but it's coming in the next build. Basically, you can already test it now. About a year and a half ago, I created this thing called the clown car technique, which I'll mention a little bit. We have image sort set, and for polyfills, we have picture fill. So earlier we talked about not doing polyfills, but picture fill is actually a good one. So the clown car technique is basically sticking all your images inside an SVG and then putting that in an object. And the object will resize just like an image would resize as you resize your screen. So what I'm doing right there is I'm actually resizing the page. You can't see the resize of the page. I should have put a shadow on the page itself. But as I resize the page, it's pulling a different image based on the media query. The code looks like this. It's basically an SVG, and depending on using media queries within the SVG, I say if it's between 400 and 700 pixels, use the medium-sized image. If it's smaller, use the small. If it's bigger, use the big. And then I put that in an object, and the object actually is 50% of the page, and it grows and shrinks as the page grows and shrinks. And the resource right there is the full article. Now the thing is, if I do say so myself, this was a brilliant idea, but it's actually not the best idea in the world in that implementation of it. Because when you resize an image in the browser, your browser has to decode the image, then resize it, then decode it before it renders it. So if you look above, that's a scaled image, and that is in the blue is the CPU used to decode the image. The green is the frames per second, and the purple is when it renders. The bottom one is using an image in the actual size of the image, and you see how little resources are used. The one on top is when it's resized. So a better solution would actually be this. I just put 2 slides in the wrong order. As it grows, it jumps. So it's actually using the image in the default size that it is. So instead of making it fully squishy, I'm actually pulling in just the right size image for that page. So why is that important to do it that way? Because this was a test I ran. I basically took 2 huge images. It's not actually this image. But when I just said background size auto, it took 24 milliseconds to decode and render that image. When I said background size contain, and the container was the exact same size as the image, it took 50% longer. So I'm still going to be running more tests to see how this handles with foreground images, but basically that thing that we learned in 1999 or possibly earlier of don't resize images is still true. If you're just downloading one image, it doesn't, like the 36 milliseconds might not be a huge pain, but if you're animating this, can you imagine trying to fit 36 seconds into your 16 frames per second allowance? No, you can't do it. Okay, so this would be a better solution. So the next step, this would be a better solution. Let me show it to you fully. And back again. Okay, don't go back again. Okay, so we want to make the other thing we want to do is we want to make fewer HTTP requests and DNS lookups. When you're at home, your computer is online. Whether it's Wi-Fi or it's actually tethered, you are always connected. And so your requests are instantaneous. When you send a DNS request, the ping is picked up right away that you want to make this request, and then it shoots out and makes a request, and it comes back with the IP address, and then you can make all your requests. When you are on a phone, your radio is not always connected to the tower. Your radio first has to wake up, and then it is awake. So your phone is doing its job, but the tower is not keeping a constant connection with you. So the biggest latency is not just the fact that you have to connect and connect and connect and connect because it's detaching from you, but also there's air. There's way more air between your cell phone and the closest tower than there is between your cell phone and your modem at home. So when you first do the DNS request, you go from your mobile device to the cell tower, from the cell tower to your phone company, from the phone company to the server, and then it sends it back to the server sends it back to your phone company, back to the cell tower, and back to your device. And I'm having my picture taken. That's a long time. That's much longer on a mobile device using a network, a cellular network, than it is on Wi-Fi. And then every request, HTTP request that it does after that, it now has the DNS, but it still has to go through 8 steps instead of 2, right? Back and forth. So what you want to do is you want to reduce the number of requests that you make. Basically, this is just saying latency is your real performance killer. Okay, so just a few more things on this. So a few ideas on how to do that is to use sprites, which is, one image holding many little images, to concatenate your CSS, to concatenate your JavaScript. Basically, I assume most people know these things, but these are vitally important on when you're using a cell network. But another thing you need to realize is you might not need that JavaScript file. You don't need to send jQuery to a mobile device if all you're doing is using jQuery to do add event listener and other browser equalization things, because your mobile device actually understands most of what jQuery was invented to do. So if you're using it for the simplicity of the $, just use query selector all. Okay. So yes, you want to make your site squishy. And the breakpoints, as we saw from that second slide, Don't give it breakpoints based on the iPhone. Give it breakpoints based on where your design starts looking bad. Reduce the number of HTTP requests. Reduce the page weight by shrinking images and only sending the images down the pipes that your site actually is going to use. Use the right input methods. There's a link there to a form talk that I do. If you're on a mobile device, if you're creating a form, use the new input types of mail, URL, phone, so people get the right, make it really responsive, so they get the right keyboard. And design for mobile first. So, we talked about bandwidth, but we didn't really talk about memory, battery, or responsiveness. So I'm going to go into that a little bit. So remember this slide that I showed you with the right size image versus the resized image? Look at the blue. Look at the CPU used on that device, just by that one image. That's a lot of CPU. When you're using CPU, you're draining the battery. So Scott wrote, is your battery draining too fast? Turn off everything that makes your smartphone smart, and that'll fix it. Because, I did not put that slide in. Okay. When you are on a mobile device, you are not just running your website. You are running the phone. You are running notifications from your Facebook and your Uber and your Foursquare, and I have no clue what you guys use out here in Italy. Facebook, those are all running in your users. So they're sharing their calendar and their phone and everything else. Your website and the browser are sharing the limited memory. This has 16 gigs of RAM. Does anyone here have a phone with 16 gigs of RAM? Didn't think so. Okay, so realize that you're sharing that memory, and when a mobile device browser runs out of memory, it doesn't reallocate, it just simply crashes. Not the best user experience. So to reduce the amount of memory consumption, images is just repainting and re-rendering the images is when you're using it. Also, CSS animations will use up memory. But your JavaScript is the biggest memory hog. And when you already know this, but this is more important when it comes to mobile space, which is when you include a JavaScript file, it gets downloaded, parsed, and executed, whether or not you need anything in that file. So that jQuery for the $, don't include it. Just use document.querySelectAll and select your nodes that way. Defer your downloads as well. So async can work if it's okay for your files to be asynchronous, such as if you have a third-party script that's just your Facebook like button widget. Leave those out if you can, but if your boss insists, that can get an async. But your own JavaScript should get a defer so that the page can load and download the JavaScript when it's available. And then when you're using Ajax, that wakes up the radio. So once your radio will go to sleep after about 10 to 15 seconds of lost connection. If you're making an Ajax request every minute, like the like button used to on Facebook, that's waking up the radio and killing the battery. So don't do that. Just prefetch. Okay, I already said the first two. I already said all those. And the last one is really important. Don't let third-party scripts be your single point of failure. By single point of failure, I think half the web went down about 2 years ago when Facebook went down, and everyone who had a Facebook widget, their site went down. Facebook has since fixed that problem, so that doesn't happen again. But don't let some other, make sure that your scripts from third-party vendors are not blocking your site. Okay. To reduce the CPU usage, avoid reflows and repaints. Minimize the JavaScript. Don't load resources, obviously, that you don't need. That is a bandwidth and a CPU issue. Avoid JavaScript animations, and if you're going to animate with JavaScript, use request animation frame. And this is kind of an iffy subject because mobile devices actually handle JavaScript animations really well. So if you're going to do something really complex, a really complex animation, use JavaScript and use Canvas. But if you're going to do a simple JavaScript animation, use CSS. And avoid waking up the radio by prefetching. this shows animation, and this slide is kind of a little bit off because the scale on the bottom looks like it's the same height as the top one, but the scale on the bottom one goes to 100, and the scale at the top one goes to 250. So basically, CSS animation for simple animations uses a little bit less than 50% of the CPU than JavaScript. But for a complex animation, when you're doing such complexity that you would be heating up, if your computer is getting warm, imagine what it's doing to the battery on your mobile device. Think of it this way. Let me just go back for a second. Think of it this way. Your users know that their GPS and their phone is draining the battery. They don't think your website is draining their battery. So don't drain their battery. They won't be mad at you because they won't know that you're at fault. But do the right thing and don't drain their battery. Okay, this is a slide was supposed to be a while ago. This is what was on my mobile device when I first turned it on. So this is what my browser was sharing with the rest of the world. I mean, my browser was sharing with that limited CPU with all of these apps that came on by default on my mobile device, leaving me with 73 available megs, and possibly 325 because I didn't actually know how to read this. But what website is smaller than 325 megs? Most of them. But if you have other apps running, that's not much room. Okay, so to minimize also the CPU and battery usage, you want to minimize the number of nodes. Because when you repaint, or when you reflow the page, it measures every single DOM node. So the fewer number of DOM nodes, the less battery you're going to consume, and the less memory you're going to consume. Cache your DOM lookups. So if you're going to look up from the DOM and first of all, don't ever re-implement scrolling. Your browser, your phone does it perfectly well. Don't try to re-implement it. Because when you're doing that, you're actually getting the height of your page. And every time you measure the height of the page, or try to find exactly where you are, your browser has to reflow and repaint the page, which kills the battery and makes your site janky. So don't do that. Cache your DOM lookups. And then when you do DOM manipulations, do them all together, and then put your new content back into the page. Don't do don't do an if-else a loop and add a list item. Do a loop and add nodes to a div in memory, in a JavaScript variable, and then put it all together at once on the page. So one other thing is something that's become very popular is to put everything client side. And there's a lot of applications that are doing everything client side, and I would assume from Jeremy's presentation that Instagram is probably one of those because nothing rendered when there was no JavaScript. Now the thing with that is I just told you that the JavaScript kills the battery and the JavaScript eats up the CPU. So Node is actually making battery usage and CPU consumption, it's lowering it because it's actually putting stuff back onto the server. If you can, put that stuff back onto the server. Don't put everything onto your user's device. And the last thing I want to touch upon is user responsiveness. So this is once a device, you actually got the site to the user in a time that is fast enough for them to want to stay on your site and interact with it. And now that they're interacting with it, you don't want to upset them. And so to not upset them, you want your application to react, and you want to react quickly. So you want to aim for a really quick response time. Here it says 100 milliseconds. That's what you're aiming for. But definitely keep it under 200 milliseconds. There's been numerous studies that say after 200 milliseconds, users notice a delay. So if your delay is going to be more than 200 milliseconds, and it will be more than 200 milliseconds if you are trying to wake up the radio to go make an AJAX request to pull more information. It will be more than 200 milliseconds if they are not on their broadband, but rather on a cell network. So if that's going to happen, let them know that you received their touch and that you are getting their request. So give them a bouncy ball, give them a spinner. I don't care what you do. Just let them know that you know that they've hit the button. And then also keep your re-rendering time below 60 frames per second. So if you're doing an animation, or if you're changing, like, it's basically mostly for animations and transitions. If you're animating an image that is huge, it is going to take more than 16 milliseconds to repaint. If you're doing a JavaScript function that needs to reflow and repaint the page, it is usually going to take more than 16.67 milliseconds. You have 16.67 milliseconds per frame. Make sure you stay underneath that. So use your tools. I'm going to see if I can open it. There's all the tools you want in the world right here. It's in your browser. Use those tools and use webpagetest.org as well to actually test what's going on with your website. Well, it's easiest to test in the tools in the timeline. And then with touch events, if you say zoom no, which, are you guys ever going to use scalable no in your meta tag? No, thank you. But if you do, that is something people do, then when someone single touches, they can use a lot, newer devices will actually go fetch it right away. But if you haven't done user scalable no, and when you touch once, the browser will wait for you to touch again or not touch again. So it'll wait up to 300 milliseconds before actually doing the click event. And it's using a click event instead of a touch event because 99% of developers only use click handlers instead of touch handlers because they're not thinking mobile. So you should be using touch handlers, but if you don't use touch handlers, click handlers still work. But what happens is it waits 300 milliseconds, and you don't want it to wait 300 milliseconds if someone just clicked on a button, right? You want to react right away. They're not going to double click on that button to zoom the page. They're going to single click. So this is the one and only time where you want to usurp user actions and just add an event listener, and so it happens right away. So even though a button will natively go and submit the form, it's okay in this one event to actually add an event listener to submit the form, and then prevent, default on whatever events you're going to do because you've already sent it. So you either want to do it on click, or it's not either. You want to do both for click and on touch end. So usurp that action on touch end so that you're not waiting 300 milliseconds because 300 milliseconds is way too long. Okay. So in general, what I recommend to people, and I'm not the first person to come up with this, but I don't know who actually came up with the idea. So I would like to give credit where credit is due. But I don't know who actually came up. I've heard it from so many sources that I don't know who to give credit to. But what you want to do when you start developing a website is you want to come up with a performance budget. And this will help you sell this to your boss, because your boss will want to add, this. I saw this one website and it had a slideshow of images that were seriously this big. So if you had this small device or if you had a big device, the images were all this big. And it went through all 4 of them, and everything was below the fold. And the guy was like, "Do you like my website?" And I'm like, "I'm sorry to be rude, but no, I don't." And then a week later, he asked me again, and I'm like, "I already insulted you last week. Do you really want me to insult you again this week?" But what he didn't do is he didn't start with a performance budget, which is decide how many requests you want to make or you're going to allow yourself to make, and what the file size of your whole app is going to be before you start developing. And you're probably not going to stay within your budget, but it gives you something to argue for. Like every time you want to add something, see where you can take away. So if your boss says, "I want that slideshow," say, "You know what, you can have that slideshow, but then we can't have any content or a shopping cart. Which one would you like?" And that way you have a basis from which to start and basically argue for the entire time. So maybe it was Luke Jones who came up with it, I don't know. But good design is not about making something pretty. It is about making something usable and intuitive. The beauty of the product will be a result of these things. So you can make your site as squishy and as pretty as you want, but if it takes 27 seconds, or in the case of Disney, 43 seconds to download onto your device, no one is going to see it, and it doesn't matter that it's pretty. And that's pretty much what I have to share with you today. But I do have time, I think, about 3 minutes for questions, if anyone has any questions. I can't see any of you, though.